Sampling Design and Sampling Procedures, Chapter 16, Business Research Methods. So after studying this chapter, we should be able to explain reasons for taking sample rather than complete census, describe the process of identifying a target population and selecting a sampling frame, compare random sampling and systematic non-sampling errors, identify the types of non-probability sampling, including their advantages and disadvantages, summarize the advantages and disadvantages of different types of probability samples, and discuss how to choose an appropriate sample design, as well as challenges for internet sampling. So the introductory example here is about changing pocketbook problems for today's family. So it's easy to ask people what they consider to be most pressing financial problems they face, from low wages to rising healthcare and housing costs and concern of too much debt. All these type of problems are constantly in the mind of many families today. And each quarter, Gallup Corporation develops a representative sample around 1,000 US adults age 18 and older to capture this public perception of a variety of relevant topics, including financial concerns of the families. And interesting trends suggest that the most important financial problem facing families can often change over time, so it's dynamic and may be reflective of the respondents' current awareness of the financial challenges of the day. Responses are usually open-ended and they are coded based upon the theme of the response. This is what Gallup is doing. So the implication of these types of changing trends is that the financial problems facing families evolve over time, and families often look no further than their own pocketbook for or credit card statements when they consider their greatest financial challenges. So the use of this large-scale representative sample by Gallup Corporation helped reveal these interesting trends. So sampling is a familiar part of a daily life. A customer in a bookstore picks up a book, looks at the cover, skims a few pages to get a sense of the writing style and the content before deciding whether to buy it or not. Similar other examples, and it's selecting in college, on the basis of a classroom visit may not be a scientific sample, but in a personal situation may be a very practical sampling experience or a course. And when measuring every item in a population is impossible or inconvenient or too expensive, we intuitively take a sample. So sampling is a commonplace in daily activities, and these familiar samples are seldom scientific. But for researchers, the process of sampling can be quite complex. And sampling is a central aspect of business research, requiring in-depth examination. Now, a little bit about terminology in sampling. A population, or the universe, is any complete group, for example, of people, sales territories, stores, or college students that share same common set of characteristics. The term population element refers to an individual member of the population. Researchers could study every element of a population to draw some conclusion. A census is an investigation of all the individual elements that make up the population, a total enumeration of every element of interest. So typically, business research do not conduct a census of a population, but rather select a smaller number of the population elements, and this is the sample. A sample is a subset or some part of a larger population. The purpose of sampling is to estimate an unknown characteristic of a population. When and in the end to draw conclusion for the whole population, but it's too difficult, it's too expensive to do it on the population, on the whole population. Why we sample? I pretty much kind of give you a hint. in a scientific study, it's in which the objective is to determine an unknown population value. Why should we sample rather than a complete census? Yeah, in order to take a complete census, and we have pragmatic reasons. Applied business research usually have budgets and as well time constraints. A researcher who wants to investigate a population with an extremely small number of population elements may elect to conduct a census rather than a sample because of the cost, labor, and time. But for when a researcher wants to contact, I don't know, millions of customers, buyers in a store, for example, it would be inaccessible. Yeah, maybe it's too expensive. It would be impossible to contact all the people, I don't know, all the customers who buy a specific car, for example, brand. It's pretty much limited. Yeah, it's limited access to the total population. So the advantage, it's sufficient that using a sample rather than the census, sampling cuts the cost, reduces the labor requirements, and gathers vital information very, very quickly. Accurate and reliable results as well. Another major reason for sampling is that the most properly selected sample give results that are quite accurate. So while not very common, in some situations a sample may be more accurate than a census. Yeah, interviewers' mistake, tabulation errors, and other non-sampling errors may increase during a census because of the increased volume of work, but in a sample, increased accuracy may sometimes be possible because of field work, and tabulation of data can be closely supervised. Destruction of test units. Many research projects, especially those in quality control testing, requires a destruction of the items being tested. Cars, yeah, when you test the cars, NCAPP test, or you wish to find out different qualities about cars, and you need to destroy that product. It's a research strategy experiment. So if there's a finite population and everyone in the population participates in the research and cannot be replaced, yeah, no population elements remain to be selected as a sampling unit after. So if the test units have to be destroyed or ruined for the purpose of the research project, then obviously sampling is obviously way better. In US and almost all the countries, they have their statistical websites. In US, is US Census. In Canada, we have Stats Canada. In Europe, we have Eurostat, and they have sophisticated and detailed data about different macroeconomic indices. Now, these are the stages in a selection of a sample. We need first to define the target population, select the sampling frame, determine the probability or non-probability sampling method that we're going to choose, to plan the procedures, determine the size, then do the actual sampling units, and in the end we need to conduct the field work. And we're going to go slowly a little bit through all of these ones. The first one, defining the target populations. Once the decision to sample has been made, the first question concerning identifying the target population. What is the relevant population? And in many cases, this question is easy to answer sometimes. For consumer-related research, the appropriate population element frequently is the household rather than an individual members of the household, for example. At the outset of a sampling process, the target population must be carefully designed and defined so that the proper sources from which the data are to be collected can be identified. Second one, sampling frame. A list of elements from which the sample may be drawn is called a sampling frame, and the sampling frame is as well called the working population because these units will eventually provide units involved in the analysis. what they do. Sampling service list related to, here we have a mailing list directory, for example, and they provide different information that's contained in a phone directory. Listing maybe by city, by street address, or by phone number rather than alphabetically. Directory is particularly useful when the researcher wants to survey only a certain geographical area of a city, for example. This is the mailing list directory page. Sampling service and sampling units. Sampling frame error occurs when certain sample elements are excluded or when the entire population is not accurately represented in the sampling frame. Population elements can be either under or overrepresented in the sampling frame. About this directory and reverse directory, I mentioned it. Sampling frames for international research. The availability of sampling frames around the globe varies dramatically. Not every country government conducts a census of the population, and in some countries phone directories are incomplete. Maybe there are no voters registrations lists, maybe accurate maps of urban areas are not there. So researchers can build a sampling frame relatively easy because in countries like Japan or Asian countries, the governments release the census information on a regular basis. Sampling units. Sampling units, during the actual sampling process, the elements of the population must be selected according to the certain procedure, and the sampling unit is the single element or group of elements subject to selection in the sample. And we have here, if the target population has first been divided into units, additional terminology must be used. A unit selected in the first stage of sampling is called primary unit, primary sampling unit, or PSU. A unit selected in successive stages of sampling is called secondary sampling unit, or tertiary if we still need 3, depends how many we need. When there is no list of population elements, the sampling unit generally is something other than the population element. So in the random digit dialing study, the sampling unit will be the phone numbers. For example, random sampling errors and non-sampling errors. A random sampling error is the difference between the sample result and the result of a census conducting using identical procedures. Random sampling error occurs because of chance variation in the scientific selection of sampling unit, and the sampling units, even if properly selected according to the sampling theory, are not likely to perfectly represent the population, but generally they are reliable estimates. Random sampling error is a function of the sampling size. As the sample size is increasing, random sampling error is decreasing. So it's possible to estimate the random sampling error that might be expected with various sample sizes. Systematic sampling error or non-sampling error results from non-sampling factors, primarily the nature of a study's design and the correctness of the executions. And these errors are not due to chance fluctuations in this case. Less than perfectly representative sample, random sampling errors and systematic errors associated with sampling may combine to yield a sample that is less than perfect representative of the population. The total population is represented by the area of the largest squares, and sampling frame errors eliminate some potential respondents. Random sampling error may cause an imbalance in the representativeness of a groups, and additional errors will occur if individuals refuse to be interviewed or cannot be contacted. So we have these such non-response errors that may also cause the sample to be less than perfect representative, and then the actual sample is drawn from a population different or smaller than the ideal ones. And here we can see the total the sampling errors, the total population, the frame error, the sampling frame, the planned frame, and the respondent, the actual sample rate. Yeah, and we have sampling frame error, random sampling error, and non-response errors. So you see, from that many, in the end we have only a few respondents. Probability and non-probability sampling. In probability sampling, every element of the population has a known non-zero probability of selection. In addition, a probability sample has an element of true randomness in the selection process. The simple random sample, in which each member of the population has an equal probability of being selected, and is the best known probability sample. In non-probability sample, on the other hand, the probability of any particular member of the population being chosen is unknown. So the selection of sampling unit in non-probability sampling is quite arbitrary, is random, as researchers rely heavily on personal judgment. Technically, no appropriate statistical techniques exist for measuring random sampling error from non-probability sample. So that's why the projecting the data beyond the sample is, technically speaking, statistically inappropriate. Non-probability sampling, although probability sampling is preferred, we're going to discuss non-probability sampling just to illustrate some potential sources of errors and other weaknesses in sampling. Convenience sampling, as even the name suggests, the convenience sampling refers to sampling by obtaining people or units that are conveniently available. A research team may determine that the most convenient and economically method is to set up an interviewing booth from which to interpret consumers at the shopping center, for example. Yeah, we presume that it will reflect the public opinion. Researchers generally use convenience sample to obtain a large number of complete questionnaires quickly and economically, and when obtaining a sample through other means is impractical. Research looking for cross-cultural differences in organizational or consumer behavior typically use these convenience samples, and then rather than selecting cultures with characteristics relevant to the hypothesis being tested, the researchers conducting these studies choose the cultures to which they have access because they speak the same language or they have contacts in the specific culture organization. Judgment or purposive sampling is a non-probability sampling technique in which an experienced individual selects the sample based on his or her judgment about some appropriate characteristics required of the sample member. And researchers select samples that satisfy their specific purpose even if they are not fully representative. CPI, the Consumer Price Index, is based on a judgment sample of market basket items, the housing cost and other selecting goods and services expected to reflect the representative sample consumed by most citizens or most Canadians or whatever country you are taking into account. And the last one, quota sampling. The purpose of quota sampling is to ensure that the various subgroups of a population are represented on a pertinent sample characteristics to the exact extent that the investigator desire. And stratified sampling, a probability sampling procedure described in the next section, also has this objective, but we should not be confused with quota sampling. In quota sampling, the interviewer has a quota to achieve. This is what they have to do, and the interviewer is responsible to finding enough people to meet the quota. You have to interview, you are assigned 100 interviews, so you need to find I don't know, 70 full-time students, 25 part-time students. The interviewer is responsible for finding enough of them and then aggregating the data of a sample that represents the desired proportion of each subgroup. And the example this is about the quota sampling. The American Kennel Club tries to keep pet owners out of dog houses, and they organize a dedicating promoting the purebred dogs, their health and well-being in family companions. And the objective of the survey is to help dog owners understand the concerns of the neighbors so that they can provide better education to responsible dog ownership and contributing to community harmony. So they have a quota and address the pleasure of a pet companionship as well the duties. It's not only and the duties, the benefit, but as well you need to see that you have duties when you have a dog. So this is the non-probability sampling as well. Possible sources of bias. The logic of classifying the population by pertinent subgroup is essentially sound. However, because respondents are selecting according to a convenient sampling procedure rather than on a probability bias, the hazard selection of subjects may introduce bias. And quota samples tend to include people who are easily found, willing to be interviewed, it's kind of field workers are given considerable leeway to exercise their judgment concerning the selection of the actual respondent. There are advantages of quota sampling, and the major advantage of quota sampling over probability sampling are speed of the data collection, the lower the cost, and the convenience. And although quota sampling has many problems, carefully supervised data collection may provide a representative sample of various subgroups within a population. Quota sampling may be appropriate when the researchers know that a certain demographic group is underrepresented and the population are more likely to refuse to cooperate in a specific survey. The next one is snowball sampling. A variety of procedures are known as snowball sampling, and they involve using probability methods for an initial selection of respondents and then obtaining additional respondents through information provided by the initial respondents. And this technique is best used to locate members of rare population by referrals. And reduce the sample size and the cost are a clear-cut advantage for snowball sampling. But bias is likely as well to enter in this study because a person suggested by someone as well in the sample has the higher probability of being similar to the first person and giving you the same responses. But sampling is used to locate in focus groups as well. When you don't have enough subjects, then this is what you use. Sampling may be appropriate. Probability sampling. All probability sampling techniques are based on chance selection procedure, and because the probability sampling process includes an element of true randomness, the bias inherent in non-probability sampling procedure is eliminated. Random refers to the procedure for selecting the sample. It does not describe the data in the sample. And randomness characterizes a procedure whose outcome cannot be predicted because it depends on chance. This is probability sampling. And we have simple random sampling, the sampling that ensures each element of the population will have an equal chance of being included in the sample. This is called simple random sampling. And I don't know, drawing names from a hat. Or selecting the winning raffle ticket from a large drum. Although drawing the numbers and names or spinning, rolling the dice or a roulette may be appropriate to draw a sample from a small population, when the population consists of a large number of elements, then the sample selection is based off tables of random numbers that we can use. Systematic sampling. Suppose the researchers were to take a sample of 1,000 from a list of 200,000 names. With systematic sampling, every 200 names from the list would be drawn. And this procedure is simple and straightforward. The starting point is selecting by a random process, then every nth number on the list is selected. So to take a sample of consumers, every 23rd name may be selected in that sampling interval. So you take the nth number. It's not actually a random selection procedure, it's that yield random results if the arrangement of the items in the list is in the random. And the problem of periodicity occurs if the list has a systematic pattern and if it's not random in character, for example. And stratified sampling, the usefulness of dividing the population into subgroups or strata whose members are more or less equal with respect to some characteristics is about quota sampling. But the first step is the same for both stratified and quota sampling, choosing the strata on the basis of existing information. However, the process of selecting sampling units within the strata is substantially different, and in stratified sampling, a subsample is drawn using simple random within each stratum, and this is not all the time true for quota sampling. The reason for taking a stratified sample is to obtain a more efficient sample that would be possible with simple random sampling. Another reason is to make sure that the sample will accurately reflect the population on the basis of the criterion or the criteria used for stratification. And there's the concern that sometimes simple random sampling yields a disproportionate number of one group or another, and the sample ends up being less representative than it could be. These are the probability sampling. Now, proportional versus disproportional sampling. If the number of sampling units drawn from each stratum is in proportion to the relative population size, the sample is proportionally stratified. And in a disproportional stratified sample, the sample size for each stratum is not allocated in the proportion to the population size, but is dictated by analytical considerations such as variability, for example. So a disproportionate stratified sample could also be selected to ensure an adequate number of sampling units in every stratum. And sampling more heavily in a given stratum than its relative population size is not a problem if the primary purpose of the research is to estimate some characteristics separately for each stratum, and if the researchers are concerned about assessing these differences between different strata. Here we have an example. Here we have the percentage of the population, proportional sample, and then a disproportional sample related to warehouse clubs, the chain stores, and small independents. Cluster sampling. The purpose of cluster sampling is to sample economically while retaining the characteristics of a probability sample. Think of a researcher who must conduct, 500 personal interviews with consumers scattered around Canada. And then the travel cost is likely to be enormous because of the amount of time spent of traveling is substantially greater than the time spent in interviewing process, for example. So in a cluster, the primary sampling unit is no longer the individual element in the population, but a large cluster of elements located in the proximity of another one. grocery stores, and then the proximity cities. And then the area sample is the most popular type of cluster sample. Grocery stores, like I said, may randomly choose several geographical areas as the primary sampling unit and then interview all of a sample of grocery stores within this specific geographic cluster. Cluster sample frequently are used when lists of sample populations are not available, and ideally a cluster should be heterogeneous as the population itself, a mirror image of the population. But then the problems may arise when cluster sampling if the characteristics and the attitude of elements within the clusters are too similar, on the other hand. This is about clusters. How we can generate relative representative sample, full enumeration, cache method, and who has the last birthday. We just take some clusters randomly. So far, we've described two-stage cluster sampling, but now about multi-stage area sampling involves two or more steps that combine some of the probability techniques that are already described. And typically, geographic areas are randomly selected in progressively smaller, lower population units that we do. Researchers may take many steps to as many steps as necessary to achieve that representative sample. And yes, smaller geographic areas are chosen until a single housing unit is selected for interviewing. And here is the illustration. You choose, we have the whole country, and then we go to the primary area, sample location. We just have a chunk here, and then we have a segment, and then the simple only one housing unit in the end that we're gonna decide. And as well, there are hierarchies as well. In an urbanized area, we can go from area to central city, urbanized area, and then exactly till you go to a specific block. So step by step. What is the appropriate sample design? A researcher who must decide on the most appropriate sample design for a specific project will identify a number of sampling criteria and evaluate the relative importance of each criterion before selecting a sampling design. And this relates with the degree of accuracy. Selecting a representative sample is important to all researchers. However, a degree of accuracy required or the researcher's tolerance for sampling and non-sampling error may vary from project to project. Resources. The cost associated with the different sampling techniques varies tremendously. And if the researcher's financial and human resources are restricted, certain options will have to be eliminated. It's the cost. Time. Researchers who need to meet deadlines or to complete a project quickly will be more likely to select a simple and less consuming sample design. Advanced knowledge of the population, availability of a list of population members is as well an important criteria, and in many cases no list of population elements will be available to researchers, especially if when the population element is defined by ownership of a particular product or a brand, or experience in performing a specific job task or something related to quality. National versus local project. Geographic proximity of a population element will influence the design sample as well, and when population elements are unequally distributed geographically, a cluster sample may be much more attractive. And stress and tension. When students arrive in the campus, in a new campus, for example, students are surveyed when they arrive and at the end of the first year, and it's not good to engage in negative behaviors and better be optimistic and socially oriented. Using a panel approach within a sample of the students over time is the best thing to do. And about internet sampling. Internet surveys allows the researcher to reach a large sample rapidly. Advantage and disadvantages, obviously. Sample size requirements can be met overnight or in some cases almost instantaneously. A researcher can release a survey in the morning and have the data back in the afternoon, or the next morning. And rapid response rates are expected, and a sample from an internet survey should be measured out across global regions or global time zones or national studies. The easy and the low cost of an internet survey as well contributed to a flood of online questionnaires, some more formal than others. Frequent internet users may be more selective about which survey they'll bother answering. But the researchers, there are disadvantages, is the lack of computer ownership and the internet access amongst certain segments of the population. In some regions of the world, internet availability is limited, and the sample of internet users is representative only if the internet users who tend to be younger, better educated, and more affluent than the general population. So it's not to say that all internet samples are unrepresentative of all the target populations, but we need to be careful and to be aware of these potential sampling problems that can arise due to this dramatic characteristic of heavy computer users. Website visitors. Many internet surveys are conducted with voluntary respondents who visit an organization's website intentionally or by just happening. And these unrestricted samples are convenience samples. They may be not representative because of the haphazard manner by which many respondents arrive at a particular website or because of the self-selection bias. Randomly selecting website visitors can as well be a problem, possible of overrepresented the frequent visitors on a specific website. We can discuss about panel samples, and drawing a probability sample from an established consumer panel or other pre-recruited membership panel is a popular scientific and effective method of creating a sample of the internet users. Recruiting ad hoc samples, obtain or create a sample frame from email addresses on an ad hoc basis, may create a sampling frame offline or online. Databases containing email addresses can be compiled from many sources. Customer clients list, advertising pop-up windows that recruit survey participant, registrations form that must be filled in order to gain access to a particular website as well. An opt-in list to give permission to receive selected emails such as questionnaires from a company with an internet presence. Some databases contains millions of internet users who opt in for limited participation. But whatever techniques the sampling frame is compiled, it's important not to send unauthorized emails to the respondents. And if individuals do not opt in to receive the email from a particular organization, they may consider unsolicited survey requests as spam. And a researcher cannot expect high responses rate for individuals who have not agreed to be surveyed. And spamming is not tolerated by experienced internet users and can create lots of problems. So thank you so much, and I'm gonna see you next time. Thank you.